Okay, continue on with the OS dev. I'm gonna try to make an IRQ1 for the programmable interrupt controller to handle the keyboard. And if I have enough time, then I want to move on to get some basic sound working with the PC speaker. So I'll kind of get to that. One change here, as you can see, but it's very, very slight. I was just checking in between last time and now if I could just set the date time equal, basically when I'm going to show it on the screen. I was like, I already had a pointer to the same data type, so I wondered if I just dereference the pointer, if it can equal the date time struct. And yeah, you can just dereference a struct of the same data type and set it equal, and it kind of works the same way. So that's pretty cool. I did that like somewhere down here at the bottom. Yeah, right here. I was just testing that out. So instead of having to set all these values, you can just dereference a struct, which is nice, and set it equal to new date time, because these are the same data type. Well, this is new and old. The global one here, this pointer, yeah, it's the same data type. So that's cool. And that all still works. Mecrun, that all should still work. Stuff will be slower because I'm recording, of course, and this isn't in uppercase. Should all be lowercase. Yeah, it still shows, ISO formatted date and everything. So that was very small, but okay, this episode will mostly be over, getting the keyboard and maybe some basic PC speaker sound. I'll try to do that, which will only be like square wave, single voice. It won't be anything real fancy, just basic square wave sound really. But before that, I'll get to the keyboard, the IRQ1. Since right now we're just polling the data port, to get these keys and everything. And I'm not even handling it completely correctly, because if you do like an arrow key, it still sends other garbage. But we're polling the data port to do that currently, if I remember correctly. So is that under keyboard? Yeah, this git key file. So this code is not going to be changed that much, but I am going to move it over into an IRQ instead of this git key. So the interrupt request itself, when a key is pressed, the IRQ1 should fire off. And then I'm going to take, whatever scan code we get when the interrupt is fired off, and I guess maybe translate that into an ASCII key like we have in this lookup table here, and I'll put that in some area in memory that another program or process could just grab from that memory area. So instead of needing this get key function to take the scan code and translate it right here from the data port in 60, port 60 in hex, I can put this into the IRQ, and then at the end of the IRQ, we can just have something like an ASCII A in some memory location. And then when I call get key, we can just check that memory location, and if there's something there, we'll just grab it. So I think that's what I'm going to do for the keyboard, keep it pretty simple, but it'll be mostly moving this code into an IRQ, maybe making this look a little bit differently. So yeah, I'll do that here. So I'm going to open up the PIC file, we'll go down wherever the IRQs are, somewhere down here. This is CMOS. That's IRQ8. This is IRQ0, so I'll put it after, I guess, this code before date time. I'll put it here. Copy this line, these two. So instead of IRQ0 here, for the timer channel, I'll do keyboard IRQ1 handler. So it'll still be an interrupt. I'll call it keyboard IRQ1 handler, because I'm not original. And I can't type. And it'll take up an interrupt frame, even though we're not going to use the values from that. Still, it is passed on the stack. And as buffer1. Okay. So this code I'll basically be putting into the IRQ instead, and get key will look a bit differently. So yeah, I'll just move all this over. All of it over. Except for the return, we'll keep that, but I'm going to remove that and paste it over here into the IRQ. And for get key, we do want to return a key, but I'm going to have it look a little bit differently. Turns an ASCII character from a global, say from a global memory location. And it's not really getkey.inc anymore. I'm going to rename this file too, I think, to be like more of a general keyboard thing. So this will be keyboard.h. Maybe I'll do term. we're in here. So yeah, let me move that. We'll make it keyboard.h now. Then it's that. Terminal, so quit out of that. Okay. I'm going to make a global struct here that's going to go somewhere in memory. And this will just be included in like an application that has to get a key from the keyboard, I guess. I don't have like an OS general library that's included in everything, so I guess they'll still have to include this file to get a key, but that's all right. I want it to be an actual struct instead of these values here. Just like putting them into memory right here. That's kind of, it's not great, so I'm going to make an actual struct for that. And I'll have it be packed. So it's only the bytes we give it, and I'll call it last key or key info or something. I guess key info is fine. It's whatever. Make it a pointer. We're going to stick it somewhere in memory. So 0x something. I do want to put these things like into a global memory area though, just like with defines. Yeah, I do want to do that. I should probably have a file that holds all of these so I don't keep forgetting where they are, because I don't remember where the other ones are anyway. Actually, the terminal was a good thing to have. Was that buffer 3? It's not there anymore. I need to write that. So that just doesn't exist anymore. Okay, that's okay. What am I messing with here? I'm trying to think. Like what? We have these files here. So what do I want this to be called? Or do I want it like outside of all of these? Do I want like a special kernel folder in this include subdirectory? I know I want like a file to put these memory addresses into. I'm just trying to think of what naming and structure is good for that. I don't know. I could call it like config or global. I'll just call it global, I guess would make the most sense. Or not any sense because it's very vague, but that's fine. We'll make global. I'll call it global addresses, for lack of a better word. So we'll do that. Call vim within a terminal within vim. I don't really want to do that, so I just wanted to make the file there. It's control/N to escape from terminal mode. Get rid of that. So global address.h. Global addresses, I think, would be better instead of address. Well, definitions for global memory addresses. That sounds good. That sounds good. And we'll start off with the key here. So I'm going to call it key area, key info area, address. These are addresses. We'll call it address. I chose 1600 a while back to hold the key info, so I'm just going to keep it there at 1600. So what that means, do this as well, that I can include that probably literally everywhere, but I guess it won't be everywhere. It'll only be in files that are using some global address, which is probably going to be hopefully okay. We should go back into global and do global addresses. Okay, and then this can be key info address, and that should be all right. And for every file that includes this, maybe I want it to have its own special key, so its own pointer. So I can make that static, and I think that'll have that work. And I didn't change the name of that file. This is still global address. Yeah, we'll move that to addresses. There we go. So I am learning the terminal mode is why I'm using this, so I don't have to completely exit the editor and all. So what do I want to be within here? Well, I want it to be sort of what we had in the keyboard stuff. This, yeah, the input character, the scan code, and like shift and control status. I'll probably put that within this struct. So we'll just have something. The first one here would be at 1600, if that's the address. So I'll put the character there. Just call it like output character, or just character, or whole character is a keyword. Key. It's not going to be a scan code, it'll be translated. It can be ASCII, but it might be different later. I'll just call it key to be sufficiently vague. I'll have a key. The scan code is not going to be within this file, so I'm not going to put that in there. I'll probably say if shift or control was pressed, maybe. Because maybe we want to return a capital A, but you didn't press shift lately or something. I'll have them be sort of separate in here. I do have booleans as well, so I could put that, which might be another one. No, I think it's within C. That above there. My own boolean type. I'll just call it shift and control. So if shift is true, then the shift key was pressed. If control is true, the control key was pressed. Otherwise, we just have the ASCII key in here. So I think that'll be fine. But I think I'm just going to return, like, with the shift key pressed or not from the IRQ. So this key in here, when we reach it in a program, if it's a lowercase a, I don't think shift's going to be active. I think I might return uppercase a and then shift will be active, so it'll be 1 or true. But I don't know, it might make more sense to have them separated out in here, so I'll just do that. But what am I going to do to get this? So to get a key, if we're going to rely on the IRQ to fill it out in a bit when I change this logic, then it's in key info. So key info key, if I want a new key and to have like repeat work, like if I hold down, you know, a key and it types everything out, if I want that to work, and not just give me infinite key presses like I had a while back when I had it really buggy when I started this code. What I can do is blank this out first, kind of set it to null. I guess if I want to do that explicitly, it's a null character. I can say while that is null, or while not. I guess that would be the same thing, right? While not key. I also want to return this eventually. Let me have a thing to return. So I'll null it out, and while it is null, later on I'll return output. I guess we'll wait for the IRQ to populate this. So while it's null, halt. That'd be simple enough. I should make a tiny little C like inline function or something to wrap this assembly volatile line to, so I don't have to type it out the same way every time. Make like a halt loop command or C function, but that's all right. We'll just have this halt until the key is filled out. And then when it is filled out, I guess if it's a one-liner, I don't need brackets. When it is filled out, I will set output to that. Or I could just return the key from this function. Then needing an extra output, that might work. That might work. Of course, if this is included within a program, then they would have access to this anyway, but maybe they want to call getKey explicitly. Calling getKey at this point would set it to null and get a new one. So maybe if you don't need a new one, you wouldn't call this function. But if you want a different key, a new one, then yeah, you could call this to update this to null and get a key from the user. I guess would be the point of this. So I think this will work. Maybe. We'll find out. Probably not, but we'll find out. But if this isn't here, it means I need to include this within this, right? So that would be keyboard.h, because I'll need to have access to like the struct definition. If not, well, I don't think I want the get key value within the PIC, but I don't want to be, I only want to have one global definition for this struct. So hopefully this is all right. Although if I do that and this is static, that might not work. So maybe I have to get rid of that. I don't know. I'm just confusing myself. That's okay. Ultimately, I want to fill out this struct when the IRQ is done, right? So that's kind of the point of this. I know my notes and example code I have, the logic looks a bit different. So I'm like, how do I translate that and make sense while I'm talking and write it out here? This is going to be the same. The scan codes, and actually along with this, I am only using scancode set 1, and this is still the PS2 keyboard, effectively. Later on, like modern keyboards and things use USB, I'm pretty sure USB protocol. HID, human interface device, maybe. But they have their own scancode set. It's not scancode set 1, 2, or 3 like for PS2 keyboard. USB has a completely different one. But for this, I'm assuming it's scancode set 1, so I'll put that explicitly. There are commands you can send to the keyboard controller to like reset it and change the scancode set and other things, and I probably should be doing that just to ensure stuff works, instead of assuming it's going to be scancode set 1 and perfect, because it's probably not, especially on hardware. I could put that as a to-do maybe. That'll never do. Let's do add keyboard initialization and scancode functions. Do not assume scancode set 1. Okay, that'll be later. I'm also going to have just a little function here to get a key. But yeah, this will be the lookup tables for this and this. This stuff I'm not going to do. We'll do a little bit differently. So if we have access to this key info struct because it's included within this file, I can fill that out first. It depends. I can either null this out within the get key function or I can null it out within the IRQ to replace it. So I guess if they pressed a key, I should probably null it out within the IRQ. I probably don't need that. That actually makes that a little easier because I can null it out within the IRQ here. And get a new key, which I'm doing up here. In case I don't want to set this key depending on what the value is in the data port. That's why I kind of separated these variables out. But we'll read in, I have ports here, right? Yeah, ports is included. So I'll read in from the data port, which I could like define up here. Keyboard, that'll be PS2. Can I do it with a slash? Probably not. That would be better, so it's not hard-coded as much. PS2 data port. Okay, read in a new key. We're gonna have sort of what you should do is have a state machine and like a queue for keyboard commands, which is how I think OSDevWiki said to do things, because that would make more sense. Having a state machine depending on what key you get and what scan code set you're set for, because some keys have escape codes that are like prefixes and then you read in a byte after that. The IRQ1 here, for the PS2 at least, if not USB and other things, only returns 1 byte at a time from this data port. So if you're expecting like a whole string of key codes, you have to sort of somehow keep in logic within this IRQ function what byte you were at along like that string of key codes or scan codes. Like for the pause key is like 5 or 6 different bytes in a row. So you'll have to say, okay, if I get the initial byte, which is like E1 for scan code set 1, you have to say, okay, if I'm at E1, I need to go do this logic and keep waiting until I read through all of the separate bytes in that sort of byte string or stream that'll be sent. If we're just doing 1 key at a time, like I'm assuming here, then it's not that complicated. I don't have to do that, but that would probably be a better solution and better code later on to have a sort of state machine, maybe a finite state machine, I guess, technically. According to what scan codes that you get and what key that you're receiving currently from this data port. I'm not going to do that because I'm lazy and I'm a bad programmer, but maybe later we can do that. But anyway, I'm saying a whole bunch of schlock, so let's get on. I'm not going to do a while loop here. I'll change this. Actually, this code down here is not really going to be applicable, so I'm just going to move that out of the way. So I'm just going to see if we get a key. So basically, if we get a key, it's going to be above 0, so this will show up. And then I need to sort of separate on. I could use a switch statement or just a bunch of if-else-ifs. I did a bunch of ifs, so we'll do that. The shift key will be 2A. These should probably also not be magic constants, right? I can probably set those up here. Maybe even at the top of the file would be better than doing this stuff. I can do that. I'll do that after here. Like this. See, these areas should go into the global addresses, which is buffer 6, which I need to write that first. And that's address H, which doesn't exist anymore. I don't have addresses, do I? No. Okay, that's okay. This stuff. I wanted to do this before I forget. That's why I'm kind of ADHDing it up right now. Because I wanted these things to be saved before I forget them, right? I'll include that here. All right, just so I don't forget. So hopefully that still works. So, I'm doing the best thing that you should be doing, which is making a ton of changes without testing between each one. You always want to do that so that everything breaks and you're confused later when nothing works, but that's okay. I'll do this stuff here. So what was I doing? Yeah, I was going to make some more defines that aren't these data ports. So let's do the keyboard like make and break codes, I guess. Particularly for shift and control and maybe E0, like escape codes or not, but okay, we can do that. We can do shift make and shift break. They're make and break codes. So I don't know if shift make code, shift break code. That's fine. But the for scancode set 1, which is what I'm assuming here. Maybe these would be better in a list or an enum or a table or something. Yeah, I'll do that. That would make more sense in an enum, actually. So I'll do that. I don't know if that needs to be global. Probably not. We'll just put them in here. Do it above here. We'll just do enum. Confused how I want things laid out, which is always good. So I'll do shift make. It's a 2A. And all the break codes, at least for scancode set 1, if not the others, the make and break codes are differentiated by the top bit. So if the top bit, or 128 or 80 in hex, if that is set, then it's a break code, which means you release the key. You're kind of breaking off from pressing the key. A make code means you press the key down. So if you press the left shift key down, then 2A will be the scan code returned inside of this data port, hex 60. If you lift the shift key, then it'll return 2A ANDed effectively with 80, or the top bit will be set. And that value is A because you're adding 8 to 2, which is 10, and hex is A. So break would be AA. Okay, right shift, this is left shift. So call it L. The right shift key is 36. And then if you get the top bit on that, then it would be B, because 3 plus 8 is 11, which is B. So it would be B6. Okay, and then I can do control, which I don't think I wrote down right control, so I'm just going to assume left control. Major Tom to left control. I know it's on an OSDev wiki page, I don't remember which one it was on. Yeah, it's on the PS2, okay. It's on wiki.osdev.org, PS2, ps/2_keyboard, scancode set 1. This, I just clicked on this. This is what I'm looking at, right? These are the scan codes. The scan code 4 means you press the 3 key. So like I'm looking for like left control pressed or released. It's left control released. There it is. Left control press says 1D. So, I'm just looking through this list and doing that. That's all. If you're wondering what I'm doing, because I wonder what I'm doing a lot, because I don't know what I'm doing. All right, and break would be ANDed with, the top bit. So that would be 1 plus 8, which is 9. With the D. So I can do right control, which I didn't do before. The right control pressed is E0 and then 1D. So E0 being like a prefix, like sort of an escape scan code, which is why you kind of need a state machine. I might add that in a second, but right now I'm just going to do left to right shift and then left control. Right control special. And then I can call it E0 as well. E0, BEX E0, that's kind of pointless though, I won't do that. But okay, if we read a key, let's say if we read left shift make or right shift make, then I'm going to set shift on and our key info struct. Okay. We'll do break keys. It's left shift break or right shift break. Then we want to set this off. We'll do that. Do else. Since right now I only have left shift control, we'll do left shift or control. We only have left control. If left control make, which I'll add right control make, but right control make is left control with an escape scan code, so I'll just say that. And control will be true. Else if we have the break code, and this will be false. Easy enough. Okay, I do want to set a special thing for the escape code though, so I'll do that here. I'll just call it E0. There is E1 as well. Just make that false. So I'm not going to mess with it, but I'll keep it there for later. That may only be used for like the pause key or something. but I'll have E0 at least that will be used for like navigation keys, arrow keys, right control, some other things. So I'll have that. So else if key equals, we'll do E0, then E0 will be true. Bunch of else ifs. And then I'll have an else condition here. If it's none of these codes, then we'll go on and do other stuff. So if it's none of these, I only really want to count when they first press the key down. So make codes only. So I'm only going to go through this logic here if they set a make code and not a break code. So I'll do if the key ANDed with 80 is not set, or if not, key ANDed with 80. Thinking something we don't need to handle, since I'm handling E0 up here before I handled it within this stuff, so I don't think I need to handle that differently. But okay, if they got a code, I want to translate it, right? So this is scancode to ASCII. I'm just copying that word there. Paste, there we go. Can't do anything right, there we go. Scancode to ASCII key. The actual scancode returned, will be the position within this lookup table, is what I'm trying to say. The scancode returned from this data port is I'm using that as a key to look up into this sort of array here. So the enter key is like 0D, which I have laid out here, but this is actually position, I think 28. It's actually 1C in hex, which is 16 plus 12, which is, 28. So the 28th position, starting from this first byte, I'm putting a hex 0D for the enter key, so that if they press enter, I'm going to return 0D, because key 1C will be scancode to ASCII plus 1C from this dereferencing into the array. We'll return the 0D, and we can check if we got D within the program that called this. Within the program that's checking the key, we can check if we got enter or not, but I can place this key code within our key info struct to return to the program later. I don't think that made sense how I said that, but that's what I'm doing. So if they press the shift key before they press the key, then shift should be on at this point, because we don't go into this unless they didn't press shift. But if they pressed shift last time, that should be true. So I can check that here if they want the shifted key value or not. So if they got shift, if pressed shift, translate key to shifted key, we'll do that. And I can check sort of an if alpha, pretty much, or is alpha equivalent here. So if it's between A and Z, then we want to translate it. And I can just subtract 32 or hex 20. So convert lowercase into uppercase to else if. Yeah, else if it's a digit. If it's between 0 and 9, then I'm going to get the key offset into this function here, which should also be a constant, now that I'm looking at it. That should be a constant as well. So that will be num row shifts. Normally it would be num row shifts key, but since key is an ASCII value and not a numeric value, I'm going to have to translate that into an int. So I think I can just do minus 48 or hex 30. So if I got 0 and I subtract hex 30, then it will be 0, and num row shifts offset 0 will be the right closing parenthesis here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So that should work. Get int value of character offset into shifted nums, which is going to go off the side of the screen that my head's probably covering, so I'll go down a little bit. Okay, so it's not alpha and it's not numeric, it's something else. It's like a different character that we're shifting to get. So I should probably have a switch statement here instead of a bunch of else ifs, or like another lookup table. Although if I did a lookup table just for shifted keys, it may be, it would be very sparse. So maybe hashing or something would work better if I needed to, but for these, we can do something like just the specific key that they got. If I'm returning an equal key, if you shift equal, it's going to be the plus. So basically if-else conditions for this, or I could do like a switch, which might look a little bit better and cleaner, but take up more vertical space, but that's okay. I think that'd be okay. So that would be case equal, and equals that and break, right? Which would be this. So I can have one line or I can have 4 lines. It's kind of whatever you want to do. This would probably look cleaner in the long run, but I'm just gonna do this right now because it's shorter to read on one screen. But I might change it later. Let's have a bunch here. Okay, so it's not the equal key. What all am I supporting? The slash? Forward slash? Which if you just do forward slash, I don't think it's going to take it, so you have to do both to kind of escape the forward slash to get the literal, or backslash, sorry. You have to escape the backslash with the backslash to get the literal key backslash within C here, than the editor. So that's why I'm doing double. And shifted backslash is the pipe, so we'll do that. I don't remember what this key is called. This one is this backtick. We'll do backtick, which is tilde. The left bracket is going to be the left curly brace. Right bracket will be the right curly brace. The single quote, which I have to escape with the backslash. The single quote is going to be double quote, which I think I also have to escape with a backslash. So this is fun. Semicolon will be the colon. Comma will be less than. Period will be greater than. And forward slash will be question marks. I think that's all I'm going to do for this episode. We can add more later. But that's all I'll do for today. So add more shift keys here. After we get the key and we get the translated key value, I want to set that within the struct. I'll set that here. And at that point, if we got an escape code, I'm going to turn that off. So that the next key we read will not be the escape code. So I guess if you send the right control, it sends E0, and then it sends 1D, which would be the left control makes. So it should turn on control if you press right control, because it'll read E0. The next one will read 1D, which will set this to true. I guess it won't go through shift. It may set the key, which wouldn't be good, but it will set it false. So we'll see how that works. It may be a little buggy. But I think right control should work from this. It's after the handler. Okay, when all that's done, the IRQ will be done, so we have to send the EOI. That's IRQ1. So I'll do that, and then we'll get rid of this stuff that I'm not going to use. And I don't think it's this. Nope. That goes to that. Okay. So that should be the stuff we need here. I think that makes sense. I know it's like getting a Triangle of Doom territory here, going in like 4 levels. Not great, but it does work, hopefully. We'll see. There's the IRQ. So we need to add that to the kernel, otherwise the IRQ will not be picked up, and I need to add this code here. Get rid of that. We'll add the keyboard. I set that up somewhere. Here we go, right here. So hex 21 for the IRQ. It is keyboard IRQ1. Handler with int gate flags. And then we will clear the mask for that for IRQ1. Oh, which is already what I had there. Set the interrupt, set the PIT, okay. And then get key should still work, which is for 4. It says while it's null. So we don't set it to null from the IRQ. We might want to do that. Or I might want to actually keep that back into here. Keep changing my mind. We'll wait till we get a new key, and then it'll do this. Okay, so we'll null it out. That would mean we need a new key, and the IRQ will set it to null anyway, but that's fine. We'll ensure that it's null first so we can do this wait loop and get a new one. But we'll see if that works. It might not. Not too sure. Global address is 13. I know I had some of these, like this. I'm going to put into there. Let me put that up here actually in the kernel to make sure it overrides things. I'm assuming I'm going to get a lot of errors when I try to compile, but I'll do that first. See if it works for the kernel, and then I'll put it in the other programs, which will fail because git key is now different, right? Left control break, it's not uppercase. Right, yeah. That file is not found within the kernel, okay. Because it's under include. I could fix that as well, like make this look a little better without needing include every time. I might do that, because I can put like a flag when I'm compiling, or in the make file, to kind of not need this include prefix, and it would look a little cleaner. Might do that. Yeah, now the editor fails. Okay, that's what I thought. Editor keyboard get key will now be keyboard. I'm hoping that's the only change I need to make for these though, because I'm still returning a UN8. So when I call the get key function, this is still assuming we're getting a UN8. That should be the only changes that are needed for that. Hopefully. And in the calculator there. Compiles, but that doesn't mean it works. Or it does mean it works, depending who you are. So D. Nope, nothing happens. Good to know. Nothing is returned. Okay. That's always good. While that is 0, I could set it to 0 first. Maybe this is making it weird. Although that should be equivalent to 0, it shouldn't matter, but maybe that's being... I know before I had this as a separate key, so I'll just do that here. This shouldn't matter though, but it might. Then I nulled it out, and then I returned the output. This is what I had in my notes. So I set it return a different variable for the key, and then nulled this out. Which I nulled it out here anyway, but... I guess because when they press a key, this will be replaced and it won't be null and it goes on immediately. I don't know, but will that make a difference? We'll see. I'll have to debug this anyway, probably. Yeah, because I'm not getting any keys here. Let's see. I have 100. So the key is 0, so that key is not getting set, or it's being reset to 0 every time. Which is true from get key, that's fair. Let me see if that's ever actually doing anything here. Yes, I'll do this, and as input 0, I guess will be memory. No. We'll have it be output. So hopefully that puts output into EAX and halts, so I can check that memory. That's what I'm trying to do there. Set to 54D10, so AL will be 10, and that is not correct. That's the enter key. Or no, that's A. Or no, that's 16. That's 16. Okay. What would 16 be? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That'd be like Q or something. Make sure it's set the kernel correctly. Setting up the descriptor. I'm clearing the mask. I did do one other thing, but I thought it was just for box, but maybe not. And that is before clearing the mask, I'm clearing out any pending keys that aren't being handled. Is what I had. So if there's any pending scan codes waiting on the data port before we set up everything with the IRQ, then I want to clear that out because another key will not be put onto the data port until that one's cleared. So I can have a little while loop to take care of that. So the status port is 64. But while if the first bit 0 is set, then I think that means that there is data waiting to be read from the data port. So we want to read that data. I'm not going to do anything with it, I'll throw it away, but while there's data waiting to be read, I want to read the data. And this is for PS2 keyboard. Status register 64. 0 is set. It's not, there's a specific phrase. I think it's like output buffer is full. There's something like that. Data waiting to be read, something like that. So we'll wait till it's not and it's cleared out. I don't know if that'll fix that, but that's something I had. Something I had written down for a reason. And no, still nothing happens. Okay. Oh, it's make box. That's what I was trying to do. No, keys don't work on here either. Okay, so I said something wrong, so I gotta figure out what that is. So I will do that. Okay, I fixed the little bug there. It was a really easy, stupid one, but took a while to find. It was in the IRQ. It was this line, effectively. Before, this was this. So if key is left shift or as right shift make, so this means if this evaluates to true, I want to check if the key equals this. This will always evaluate to true because right shift make is not 0. So this was always setting shift to true and just not going on, which is bad. So you want to check if the key equals these values. That way that is a condition itself, not just checking if this is above 0, which it is. And yeah, that actually goes on now and returns the key. So that was a bad, little thing there, but I also added something here because I wasn't handling sort of E0s correctly for arrow keys, navigation keys, and things. I made these static, bool E0 and E1. Instead of setting it false every time, that wouldn't really be true. We want to check its condition over time, not just set it to false. So I made both of these static for the future. And then I added another condition under here, if not key and 80. I'm not going to translate the E0 code. But I will get the key if it's not E0, if it's E0 and then 1D, for example, for something like the right control key. Well, we won't do it in that case. But anyway, if it's like an arrow key, it'll still go through here. It won't really be correct because the arrow key is not visible. But I guess if we had something at that point and we could translate it, we would do so. Make like an arrow sprite or something. But anyway, that's okay. I'll translate what we do get that isn't E0. And shift them as appropriately, and then eventually return. I'm setting the key here after that E0 check. So before it was up here, so there's another bracket, it's here. And if E0, it's still false. And that's the changed thing there. Changed interrupt request, IRQ. So in keyboard in here, I don't have to set this to 0 first, since the IRQ sets it to 0, so I just commented that out in this line here. So I'll delete that. And then I did have this as well. So I don't want it to stop here anymore because it's working. So this looks a little simpler now. I'm going to keep the output just because it works, although you might just be able to return key info key and not reset it to 0 because the IRQ does that. I don't know. But I guess if we don't call the IRQ in between calling get key, we do want to set this to null first so that next time we enter this before the IRQ, we can check and not go on immediately. So I guess this is key, pun intended, having this work. But with those changes, we actually do get key presses now, and it works like it does before. So dir prints the directory. So hey, it works. Even with the global address header and the things mixed around and stuff, it seems to be okay now. So that is nice. We have keys coming in from the IRQ, not just, I mean, we are in the get key function waiting in effectively a busy loop with the halt, but other than that, we're not technically doing a busy loop on the data port anymore. We're only reading it when a key comes in, which is good. But I guess there's still some busy loop waiting. So the only remaining issue with this would be in functions that use the key, because the control key was handled differently, like in editor and calculator, to exit, for example. So calculator exit is control R or escape. So escape still works, but exit I also wanted to be control R. So control R just prints an R, so we can't escape from that. And I believe in the editor as well, we won't be able to escape. Control R should be return, but it doesn't do anything. So we have to change those. But I think that's the only other issue. So I did change, we have keyboard in the calculator. We'll just check where we're doing control here. We don't need to do that, because we have it implicitly at that section by including this file. We have it, the key info struct available. Where am I checking here? If input character is 1B or key info control and input character equals R. So control will be set if we press the left control key. I'm assuming if we press right control as well, since the E0 would be red and then it would go on. I don't know. That might not be true though. Left control and it's R should be control R and return. I'll test that here. Go into calculator, smellulator, control R. That does it. I'll see if the right control works. I don't remember if this keyboard has a right control actually. I have a fancy keyboard. I don't think it has a right control, so I can't test that. Which is not helpful. I have the HHKB. I don't think it has a right control, but we know the left control works, so that's good. That pinky will be getting a workout. Editor, I have keyboard included. And it says control R, so I don't know where I would be checking that. So I'll just search for R. If control equals 1, so if key info control. So there we go, and it's R, then we'll return. That's the only place that happens. I guess it's only in the text editor. Yeah, because the bin editor has the question mark, right? So that should be the only change we need for that. We'll just make sure the other one works. Returns, editor, make a file. You can't see it, but I'm saving a name. And we're going back here, control R, returns. And we can still print it out. Okay. Can load that file. Control R. Yeah, we're good. Okay. So we can check key info struct and the value of control. If it's true, then it's on. Off, then it's off. We could also check shift. I guess I didn't check shift keys, right? Let's do that. So F, capital F, A, capital A. So that does work. Special key would be 1, and then shift 1, 2, 3, 4, 5. So I'm holding shift down now. So I don't need to press shift every time to get the right shifted character. So that's good. You can just hold shift down now. And repeat should also work, because we're setting it to 0 in the get key function. And then whatever typematic delay, I think is what it's called on the PS2 keyboard controller set, which you can change that rate as well, but I'm not doing commands. It'll repeat for that rate, at least in emulation, and then it'll keep sending that key as a key press. So even though we set it to 0 within get key, it'll be returned, so we can have, effective key repeat. and shifted key repeat, which was not possible before. So that's actually an improvement. So that's good. That was a backtick. You can't really see that. And I still need to fix shell processing because valid input does not work. It goes on searching for stuff that doesn't exist. But other than that, weird bug. Keyboard works, so that's good. That didn't take too long. That was just a really easy bug that I missed. But okay, assuming sound works on OpenBSD, I do want to try the PC speaker sound, and if it doesn't work, then I'll just clone this project on FreeBSD where it does work, or Windows, and then I'll show you it at that point. But I want to move towards getting a little basic sound input working, so I'll do that next. Okay, actually I lied. I have a little update here because I forgot about arrow key handling and navigation key handling in the editor, which doesn't work anymore. I have to make changes for that. Forgot about that. Scan code here we don't need, I don't think. I'm going to get rid of that. This is down here in the text editor. The scan code and control key, we don't need these anymore. Input character returns with a key. This should return the arrow key, scan code, and everything. It's just translated differently. It would normally be a valid regular character like a K or something. The arrow keys aren't supposed to be visible. They're supposed to be translated differently. But we can check that within here, I think the same way, and it'll work because they'll be outside of the normal A through Z range, whatever key is returned. So I think we can still check these things, but just not with scan code. It'll be input character instead. So everywhere I have scan code, I'm going to replace with input character for the arrows and the home and end. These I don't need. Input character. I think this is in the bin file editor now. Okay, and then where I have control key, that was it. Okay. Well, we'll see. And we'll do it in C. If I make a file, line 2, so left control, or left arrow, yeah, now goes forward and back, and up and down work the same. Home and end work the same. So we're good. We're good there. That is good. Can I center the window? I can't. Thought I had a center window function, but I don't remember what the key was. But I can still save. And stuff still works. Just wanted to make sure that arrow keys and navigation keys worked. So just small change there. But yeah, I'll get on to doing the sound stuff now. Okay, so basic sound support, assuming it works on OpenBSD, which it might not. I know sound works on OpenBSD, I'm just not sure it works emulated because I had trouble getting that to actually function. So it might be silent. But I know sound works because I can do like... I think I can output this to like the speaker. Is it audio 0? So if this is really loud, I apologize. Should just be white noise, I think. Oh yeah, I'm not going to write it, but... Oh, there we go. If that's really loud, I apologize. I can lower it in post. But that proves audio is working. Just, you know. To have it actually work under QEMU, I'm just going to add another flag, and it will be sound hardware PC speaker, although this is deprecated depending on the QEMU version you use. It might be like machine, audio device, PC speaker, something, something. But this is how I know how to do it. So I'm going to do it like this for now. Okay, and I'm going to have another folder within here. I'm going to call it sound. And within sound, we'll make PC speaker.h. So we have this here. I'm going to include that within the kernel. And it was just one level up. Sound PC speaker.h. I know it's empty right now, but we'll be filling that out soon. So definitions and functions for emulated, maybe hardware, PC speaker, and pragma once. You can do more advanced audio with the speaker with pulse width modulation. I just haven't gotten it to work because I'm dumb. So I've gotten just basic square wave sound to work. But there are resources out there and there are examples, but it's only in like real mode and DOS, usually DOSBox or something. I haven't seen an example in 32-bit protected mode or long mode using QEMU or VirtualBox or something. I have to mess with it a bit more. I haven't gotten it to work, but you can technically do pulse width modulation with the PC speaker. I just haven't gotten it to work. So I'm just going to focus on, basic square wave sound. Mess with PWM and get it to work. PC speaker sound. That'll be later on. But okay, I'll just have a couple of functions here. An API for the speaker, if you will, to turn it on and off and play a note and rest. So I'll do that here. We'll have something to enable, we'll have something to disable, we'll have something to play a note. And in music, we have resting where you don't play a note, so I'll have that as well. And these will rest for given duration. Since the PIT channel 0 timer is set up on a millisecond granularity, we can wait for a given number of milliseconds. That'll enable you to play songs and things by playing a frequency or a note for a number of milliseconds, or not playing a frequency or note to rest for a given number of milliseconds. I'll just put given duration for these. And I'll put to-dos here. Okay. So enabling the PC speaker and disabling are not that bad. The port for the speaker, I guess I can put ports things up here too. The data port for it is 61. I just don't remember what the name for that is. I'll show the OS Dev wiki page for the PC speaker. In their examples, they're doing port 61. So I'm going to be using that. So basically that's wired up to channel 2 of the programmable interval timer. So if you set a given frequency to channel 2, then that will be the frequency, if you set it as a square wave, that will be the frequency that the PC speaker sort of vibrates at, because it's effectively a little piezoelectric speaker. Or if you have a laptop, I think it's moving iron or something. It's like 2 metal plates, so it doesn't sound nearly as good as the piezoelectric. It's like a tiny speaker that physically, the speaker cone moves in and out at a certain frequency to generate a certain, airwave frequency that makes a noise, makes a note. So if you set the PIT channel 2 to a frequency, that is the frequency that the PC speaker will be vibrating at and the tone or note that it will play as a square wave by default, what I'm going to be doing. I did have frequencies of musical notes. So these, basically, if you want to play a given note, you have to divide the PIT, default timer, the 1.19 or what have you, megahertz value. You have to divide that to get a frequency that plays, a given tone, say. I thought I had it online, I don't think I bookmarked it, but there should be like a tone generator. Yeah, online tone generator. So 440 hertz is standard A. So I'll lower this in case it's loud. We'll be playing square waves with the PC speaker. So it sounds like this. Triangle wave sounds a little bit better as it goes up and down. Square wave is just on, off, on, off, on, off. Triangle sounds, a little better. Sawtooth is up and then down, up and then down. A little more buzzy, but not as, it's a little buzzier. Sine wave is the smoothest. Because it's just, the sine wave. It's even samples the whole way around. But A is 440 hertz. So if you want 440 hertz, which is this thing will have that as well. That is standard A, which I think is A4. Basically, you divide PIT frequency by that value, and you get, around 2711. If we're doing square wave, this should be even, so 2710 or 2712. It's not exact, but it'll be close enough. And then what we do, if we want 440, we would send, say, 2711 to the PIT channel 2 to divide that by, which would end up being 119.3.182 divided by 2711, and that would give us 440. So effectively, the channel 2 frequency would be 440 times a second, and the PC speaker, if we turn it on and enable the bit at the data port 61 in hex, the speaker would then vibrate at 440 hertz until we turn it off, and that would make an A tone. So if that's emulated correctly and OpenBSD plays it, we should hear that. If not, then I can transfer this to another OS and that's fine. So I'm just going to have a byte here. Let's call it temp, and we're going to read in the value, whatever it is, from port 61. I'm just going to call it PC speaker port. Be very long and pedantic with our naming, that's fine. And then I'm going to write out to that port whatever the current value is, but turn on the first 2 bits, or it with 3. PC speaker support OR with 3, so set first 2 bits to turn on speaker. I should find a better spec page that explains this exactly, but this was what the examples had on OS Dev Wiki, so that's what I'm using, but this does work. To disable it is pretty simple. It's like enabling, but instead of setting these 2 bits, we would disable them, or clear them. We will clear the bits, we will read this, and we will write this ANDed with 11111100. So that would be F, and 8 and 4 would be C. So this should be FC. I'll say clear 2 bits to turn off speaker. Okay. That's effectively all we have to do. You could also, instead of putting temp separately, I don't want to write to this, I want to write temp ORed with 3. This would have failed compilation, so that's okay. I want to write out to the port the value that we got from temp. Okay, ORed with 3 or ANDed with FC. That's what I wanted to do. So you could replace temp with nbyte PC speaker. This just looks slightly cleaner. It doesn't matter. That's just how I did it. But okay, if you want to play a note for a given duration, I'm going to put void play note. I could have a list of frequencies. And I did do that before, I think as a giant enum. Yeah, to define specific frequencies, so I'll do that. We can do that. Type def enum. And note frequency, we'll just call that T, or maybe note T. Note frequency T, that should make sense, right? And A4 was it 2711? If you send an odd number, has a square wave frequency divider to the PIT, it's okay. It'll just take probably the even number below this, so it would effectively be 2710. But if I want it to be accurate in my, documentation here, I'll just say 2711. We'll divide it by that. So I'll put these frequency rates to divide PIT default rate of 2 megahertz by to get a given note. Hopefully that makes sense. We divide this number by this to get effectively 440, which will play A4. So we'll do that. So this will be constant note frequency T note, and maybe 32T ms duration, millisecond duration. And what we'll do is set PIT channel 2 to this frequency that we want to play, and then we'll wait or sleep, because we have sleep functions. We'll sleep for the ms duration. I think that'll work. So that is set PIT channel mode frequency, which means I need to actually, yeah, let's move this back down there. It's interrupts, isn't it? Yeah, interrupts. PIC. Okay, and we're using in and out, so I might as well include the ports as well. So we're using in byte, out byte. And if we're going to be sleeping, then I will have to include the sleep functions, which I put in time. So I'll need these. I don't need them, but it'd be good to include them to make sure. PIC channel mode frequency. It'll be channel 2, it'll be a square wave, and the frequency will be the note value. Okay, and then we'll do millisecond sleep. Sleep milliseconds for the MS duration. So we are also, I'll just put this here as a note. Assuming PIT channel 0 is set to 1000 Hertz for 1 millisecond. Great. Okay. That way the sleep will sleep for the right amount of time. For a rest where we want it to be silent, we can either turn off the PC speaker, or I think that's slow if you do it rapidly. So I'm just going to give it a different frequency that's like outside of the range of human hearing, we'll say. Maybe it'll annoy your dog, I don't know, but for resting, I'm going to play something like really high frequency, which will be, I won't do this. Okay, let's do something like 30K or so, because the higher range of human hearing is 20 or 22 kilohertz, right? 22,000 or 20,000. So if we want to get 30,000, which should be well above that range, we divide by 39, or maybe we'll say 40. Nice even numbers. That should be outside the range of human hearing, so we'll divide by 40. And effectively, this should switch too fast for the PC speaker, so it won't really even like switch. It'll be too fast, so it won't make any noise. But the frequency will be going. And then we'll sleep for that frequency, and it'll effectively be silent for that duration. Okay, I'm hoping this works. It might not. I could be talking load of crap, but I'll have another command here to test. I'll call it sound test. Sound test. Test PC speaker square wave sound. Okay, and that'll be down somewhere down here at the bottom because I need better structure. Here we go, sleep commands. After show date time, we'll do it here. Go up a little bit. My eye itches, it's annoying me. Okay, itchy eye taken care of, so we'll compare to sound test, and this will be sound test. Again, print that for the prompt. So I will enable the PC speaker. And then we'll play some notes, and then we'll disable PC speaker. So first, I guess I'll try to play a note, which the only one I have available is A4, so we can try to play that for a second, I guess. 1,000, it's a millisecond duration, so 1,000 milliseconds is a second. So yeah, we'll try to do that. Test, play A4 for 1 second. Of course, if the timing is wrong, and it probably is, let's say around 1 second, it might be longer. But we'll enable, play, and disable, and we'll see how that goes. No target to make. Go back and make it. So I typed stuff in right. That was good. Yeah, PC speaker is deprecated. Use a backend. I didn't know the right invocation for this, is why I'm not using it. Because there's more complicated invocations to do that. So this is probably not gonna. It's probably just gonna be silent and nothing's gonna play. Or it'll be very fast. And then just stop until the full second is up. And just never come back because it's buggy. So that's good. But hopefully you heard a beep. And yeah, this was buggy on OpenBSD. So I'm going to transfer this to FreeBSD. And then when I get that up, I'll be back. Okay, so here on FreeBSD, just cloned and, got into the project here. Making it has some more errors that aren't on the OpenBSD version of Clang. For my compiler, they're just warnings, they're not errors. Pretty much all of these are pointer sign errors where I'm just setting a constant string equal to a string and it really doesn't like it. I guess here in the calculator valid input, I just want to check really quick. This doesn't mess anything up. I just want to check if setting this to constant does anything. Like that last error there, that last warning. Yeah, it still doesn't like it. So basically what I have to do there to fix that is, where's valid input here? I have to change these to say, hey, technically it's an array. I don't know why FreeBSD is very anal about that, but yeah, and then it goes away. So the other thing we can do, I just don't care about those, which right now I really don't, is just add here no pointer sign to the warning as this warning flag. I should use other warning flags anyway, like all in, I don't know about pedantic, but you know, all in error, but I'm not a good programmer, you know this. But no pointer sign will suppress those other ones, and those were the only errors that it was, not even errors, warnings that it was warning about. But on FreeBSD, if I run this, we will hear the sound. And if you have any tips on making things work better under OpenBSD, let me know, because I like it as a development environment. But under here, sound works a little bit better. So just to show, I'm doing 1,000 milliseconds for 1 second, but it might not be exactly correct with this timer. Just so you know, I'm putting that there for a sanity check. But you should hear the tone for approximately 1 second. So there, you know, the A actually does play. I'm assuming you hear it. Play third time to check. Yeah. If that's really loud, I apologize. I'll lower it in editing, but we can play notes with the PC speaker. So now I can check if resting works, and then I can make a sort of better abstraction, couple more functions around those two, and add some more notes, and technically could play songs, which I think is kind of cool. Sound test. So I'll play for a second, and I will rest for a second. And we'll play for, let's say, half a second. Rest for half a second. You know where I'm going with this. Play for a quarter of a second. Rest for a quarter of a second. And then we'll just end and disable it. So it should go, you know, beep, beep, beep. It should be a little kind of like that, shorter each time. The good thing about FreeBSD is it's faster as well, but you know. It is a bit iffy. For some reason, it's slow to start off, but after like a minute, it warms up or is in the cache, or my host machine says, okay, I should dedicate resources to this, and it plays actually accurate on time. But starting out, it's always slower for some reason, so this should be faster. Yeah, but that just proves that, you know, playing sound and resting works, which is nice. But okay, so I'm going to just copy some other notes in. And, you know, basically what I'm going to do for the notes is just put them in here as frequencies. You know, after A4 we'll have B4, we'll have C5, we'll have D5, you know. And I'll put in sharps and flats. Flats, we can actually do a lowercase b, which looks like a flat. Actually, on sheet music, sharps is a sort of a C special identifier or even preprocessor symbol, so I can't really do that. Like I can't do, you know, F sharp 6. Like it'll count this as part of the hash, and that won't compile. It'll be like, what are you doing? So I'm going to do like an S maybe, or capital S. I'll do lowercase. That might look a little bit better for sharp, and then for flats, like E flat, I'll do a B because that looks like a flat. But other than that, I will copy. I'll basically be copying these things. I'll probably do, I don't know if I'll go to 0, but I know before when I was testing, I had 2, basically C2 up to I think like C6. So I'll probably have that range up here. So that'll be like 4, maybe 2 to 3, 4, 5, 6. That'll be 4 octaves. 2 through 6. So I think that'll be good with sharps and flats. So I'm just going to copy those, or write in those frequencies here, and I'll be back when I get that done, because I don't want to spend 10 minutes doing that and being boring on video. So okay, so I got those all written in or copied over. Got C2 to C6. Just got those frequencies in here. So if you want to know what they are, you can look in this file and they'll be here. These are, you know, again, numbers to divide the initial rate by to get the actual frequency for these notes. I did use a capital S, so I'm going to go ahead and lower those right here. I could do a copy paste, but this is satisfying, so that's why I did that. But okay, we have those notes here, so what's a little special thing we can do? We can try playing like the C major scale, say. If people don't know music, I apologize. I'm not going to be going like deep into theory or anything. Not this video. But I can't really build chords unless I learn how PWM works on the PC speaker, or I go into something that has multiple voices, like Sound Blaster or something. So we won't really be building chords necessarily. We can just play one note at a time. So there's not really music theory involved. Reading sheet music, maybe, if you want to play stuff, because I'm basing off sort of the piano key roll and sheet music. I don't play piano. I want to one day, but I have a guitar I played badly, and I played saxophone and band, jazz band and stuff, which is in the key of E flat. So I'm used to treble clef E flat tuning for saxophone. I think guitar is also in E flat or E. I don't remember, but anyway, we can play like the C major scale here. I'll just do that. C major scale test. I'll play things for like 1/3 of a second each, we'll say. C, D, E, F, G, A, B, C. D, E, F, G, A, B, C, except everything above, yeah, will be 4, and this will be 5. Okay, so we'll see how that sounds. Make it and make run. Again, it'll be slow, so it won't be 1/3 of a second each time. And again, if it's really loud, I will have edited this to be not so loud, but just for my ears, it may be loud. Okay, so that works. It actually didn't sound too bad. Let's play this for double the amount, and then we'll just go back down the scale. E, A, G, F, E, D, C. It'll go do 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 do. We'll do 6, 6, 6. Let's do rest. I like doing this because it's number of the beast, and it'll make some people irrationally angry or perturbed, so that's why I like doing this. But this just means 2/3 of a second, because it's the number of milliseconds. And we'll play C, then we'll play 5. Do, do, do. This was part of band, so I have this, you know, memorized by heart, right? Go down the scale and play your octaves. Many, many hours. See, it is slower and faster. So there you go. And then the second time through, it should be faster by default. So that's cool. But that's not really fun to do, just playing the major scales, but it's good you can do that. We have all the music opened up to us now, which is nice. But I'm going to put in some more, I don't know what the word would be, functions, APIs, abstractions, interfaces to play actual music and notes in a better manner, a more structured manner, like a song. Not the best way of doing it, of course. I'm basically sort of going to make a bootleg MIDI, but not as great and not even as complex. So if you read a piece of sheet music, I'll look one up and bring it here. So let's get the old DMCA special. straight from the lockers of Nintendo. Hopefully they don't cease and desist this video for no reason, because I'm not going to make money off of it. But if we get a vgleadsheets.com version of the overworld theme, and I will put them in the description because it's a great website. It's not all the parts, it's just the lead parts, lead sheets. But I'll be trying to make abstractions good enough to sort of play this kind of well. So I want something to set the BPM value, which is this, beats per minute. It says a quarter beat, quarter note. The time signature, although beats per measure doesn't really matter, because unless I visualize it as, bars, it's not really going to matter. But I can have like a set beats per minute function to set that off for timing purposes. I can have a time signature function, and then maybe stuff to set the default durations. Like I can call something like play 16th note, or 8th note, or dotted 8th note, or quarter note. And it should play for that given duration from a set beats per minute value. And then if you want to do this stuff, we can just have these be notes and then have like a loop, loop once or twice for playing these specific notes. Then I have sharps and flats and everything, so we just basically lay these out to play for a given duration of 16th note or 8th note, quarter note. And we should have, and we loop where appropriate, and we should be able to play a song. So I'll try to set up those abstractions here. Enable, disable. I guess before I play a note, well, that's a generic note, that's a generic rest. Yeah, so that's fine. I'll do it after here. So do set beats per minute. If I have different functions, I'm going to want stuff to be global, so I'll do it over here. I want an enum according to the type of beat that we're going to do. So beats per minute and time signature go hand in hand. And I'm not going to explain music theory or sheet music very well, so bear with me, but I'm going to call this beat type T. And this will be for time signature purposes. Time signature lower number. What type of note gets the beat? Okay. So I will do, you don't really see whole or half notes get beats very often, but I'll put these here for completion's sake, or 32-second or 30-second notes and below as well, unless something's really slow or extremely fast or something. But I guess I'll do this. Yeah, whole will be 1, half will be 2, quarter will be 4, and I don't know the actual names. I think this is brev and this is semi-brev and this is, it's not quarter, it's some weird word, but I'm just going to call it this because this is how I learned it initially. 8th notes, 16th notes. We're not really going to mess with this, but I'll put 30-second. Now I'll just put 30-second. 30-second notes. But they're all, divisible by 2, which makes things easier to reason about from a computing perspective. And let me also set, we'll do this, whole note duration. These will be in milliseconds. I think I'll make these 16ths, or maybe I should make them regular ints to be sure. That's fine. So I'm going to set up duration values as well that I use in different functions to make things easier to reason about. So whole, half, quarter, 8th, 16th, and 30-second. So we'll just have these be here. I guess if I want them to be updated over time, let's do it static. I'll just set them 0. That's fine. Because after we set them once, they'll stay set. We'll do that. Okay, so we'll have a set BPM. Given a BPM value. BPM. And yeah, that'll be fine. So what that's going to do is set these given durations in milliseconds according to the type of the beat. So, but I'll do that with another function. Just put this all the way up here. So I'm not going to be messing with the beats per measure, so I'll do that. But I'll include it here for completion's sake. Let's do set time signature given UN8T of beats per measure. And which type of note gets the beat, which is it beat type, beatnik, beat type. Constant beat type T, beat type. Okay. And for most things that I look at, they're basic, so it's gonna be like quarter note gets the beat, right? So that'll just be a 4, but we'll put that in there. So the BPM value will set, let's do a global beats per minute value. Global BPM, or let's call it BPM millisecond. So the amount of milliseconds per one beat is what this is going to be. And we'll set that value here. How would I do this? So a millisecond, you know, is 1,000 times per second, right? So 1,000 milliseconds is in 1 second. So what that means is that 60,000 milliseconds is 1 minute, right? Because 1,000 times 60 would be 60 seconds, which would be a minute. So BPM value is in beats per minute. So if you have something like 100 BPM, we want to translate that into a certain number of milliseconds. So if we have the number of milliseconds in a minute, and we're given the number of beats in a minute, we should just divide the milliseconds by the BPM value, and that will equal the number of milliseconds per beat. So minus 100 would be 600 milliseconds per, we'll say, per beat. And then according to, you know, what note gets the beat, that note, if it's a 4 for a quarter note would take up then 600 milliseconds each. And then the other notes you can calculate off the quarter note. An eighth note is half as much, a half note is twice as much. A dotted quarter note adds half its value, so it would be like adding an eighth note onto the quarter note, so on and so forth. So if you don't know anything about reading sheet music, then it's probably is really boring or going over your head, or it doesn't matter, but that's how I'm doing this. So basically BPM milliseconds will be 60,000 divided by our BPM. Assuming again, PIT channel 0 is set to 1000 hertz or 1 millisecond. So, okay. And this will be integer division, so it should be an integer number inside of this, which is up here. Yeah, okay. I'll do a switch on the beat type. And we'll have a case for each note. So let's do each beat type. We'll do whole, do half, do quarter, eighth, 16th, 32nd. Okay. And we'll use the BPM MS to set millisecond values for these, which I have up here as durations. I'll set up whole note duration, half note duration, quarter note duration, eighth note, 16th note, and 30 seconds. And then we'll break. So if we're given a beat type that's a whole note for whatever reason, that's going to get the full duration. So this is going to be the full beats per minute millisecond value. The half note is going to be half of the whole note here. So I'll do whole note duration divided by 2. Or really I can do BPM MS divided by 2, which is shorter to write. It's going to be BPM MS divided by 4, divided by 8, by 16, and divided by 32. So that's simple enough. And the half note, instead of going off the whole note, it would go off the half note. So the half note would be the BPM MS. And the whole note would be that multiplied by 2. It would be half as slow as the half note. And the quarter note duration, if the half note gets the beat, would be half of the half note, or a quarter. So all these would be divided by 2 in this case, instead of full value. And so on and so forth for the rest, right? If it's a quarter note, the whole note would be 4 times as long, the half note would be 2 times as long, the quarter note would get the full duration. The eighth note is half as long as the quarter note, 16th is a quarter as long as the quarter note, 32nd is an eighth as long. Or short, however you want to say that. So this hopefully makes sense here, and it's laid out enough to understand, right, what I'm trying to do. The eighth note gets the duration times 2 times 4 times 8, divided by 2, divided by 4. 4 times 8, 16, divided by 2. And I haven't really seen, maybe once or twice, if that stuff where the 32nd note gets the beat, it was usually very slow and maybe like a waltz or something as well. But very slow for the beats per minute value. Because otherwise 32nd notes are very fast usually. So, or like a really tight run or something in a section of music. It depends. But I was very good at sight reading, so I really liked stuff that had a whole bunch of weird sharps and flats and changing keys all the time and having weird syncopation and off rhythms and stuff. That was really fun to play, so jazz was fun. And then some parts of concert band were fun on saxophone as like a lead part for different runs and just weird signatures and beats. So maybe one day I'll get back into that, but yeah, that's just setting time signature. And then what I can do, since this is done, and I can have stuff that basically plays notes for these durations. So this does add a lot of program calls and, you know, the overhead associated with that, I guess, but I can at least make it easier to make abstractions to play music by doing this stuff. So play note here, I'm sort of going to be calling this for a given note and duration. But these durations will be affected by, you know, the type here. So let's do something like, call it whole note. And it will just take in a note value. Note, frequency T, note. And what this do will call, it will call play note. It'll call play note with that note and the whole note duration. And according to whatever the type of beat we're doing, the whole note duration will be changed, right? To a certain period of time, according to the BPM millisecond value. So I'm going to do this for, you know, whole, half, quarter, so on. Do this, we'll do, I don't know, what is it, 6p? Sure. Be half note. Should be half note duration. Be quarter note for quarter note duration. Eighth note for eighth note duration. And I don't think I need the last one. Whole, half, quarter, eighth, 16, 32nd. Which I like spelling 30 and 2 and D because that makes me happy. Voice is starting to die, it's alright. But to go along with these, I will also have rest functions, right? So I'll call it whole rest, half rest, so on. Which won't take in any harms, but we'll call rest for whole note duration. Which is, it's just rest, right? Yeah, rest. Okay. Half, quarter, 8, 16th is 4. It's 4 times, right? Yeah, I missed one. 5 more notes, 6 overall. like adding spaces between this. It's easier for me to read it. Okay, 16th, and we need 32nd. Which is the same thing. Okay. So we have rests and we have notes for given durations. So what can we do with these things? I think this is all set up now. We can either play it inline or make a separate file that we load in or something. So I have stuff set up now, actually. I have another thing set up. So I'll just show like an example, right? You saw the C major scale, but I'll show an example of, you know, the DMCA Italian Plumber song that'll play here. But I forget because I got tests here in between recording things, but I'm just looking at editing so you didn't notice. PC speaker test. Yeah. The same thing. Sound. Seinfeld did not sound good, so I'm not going to do that. Sea Shanty sounded all right, but we'll do this one. What I'm going to do is make a file. Just do this. Let's touch. That's fine. Mess with a bunch of things for no reason. So Italian Plumber Brothers is going to be the name of this this file here. And I'm just going to copy this stuff here. So that I already had before. Do a Y. All right, so all I'm doing here is I'm calling the same functions. It's just I can include this as a file somewhere to make it easier, but I already typed this out a while back. So setting the BPM to 100 approximately. Time signature is 4/4, so this is for this file here. The BPM is 100, time signature is 4/4. This is a quarter type, so I give it quarter note type. So to make this sound right, if you just play this straight from the, just send the notes and durations, the PC speaker does not turn off in between the notes, so it plays the same tone the whole time. So in order to make it sound kind of like do, you know, like syncopation, I did some weird things here, like a 30-second duration and then a stop for 30-second duration and then an eighth note and then a little rest and then eighth note. So this should play like do, you know, like a little more syncopated rhythm instead of just, because if I didn't have any rests, this would just play do. It wouldn't have any stops in between like a real person would. So this will play slightly slower and it'll be a little off, but it will basically get the theme mostly correct. Oh, I also have dotted. Yeah, I made dotted functions. I need to add those in. But other than that, and the triplet, then I think we're okay. So I need to add those in actually. But the rest should be all right. I forgot about those, so it's actually good that I copied this over. It's B1. Okay, so dotted notes will be extra. Did I only do dotted eighth notes? Yes, right? Yeah. Okay, that's okay. I'll add this in at the bottom of our speaker file, which I need to move down so my head's not in the way. So I'll put that up here. Do add more dotted functions. Okay, so a dotted note, like a dotted eighth note, just adds half of its duration onto it. So if we have something like this dotted eighth note here, a normal eighth note would play for half of a beat here with 4/4 time, but this plays for 3/4 of a beat. If you divide 4 into 4 equal 16th notes, it'll be like 1 2 3 4 1 2 3 4 1 2 3 4, and an eighth note would be 1 2 1 2 1 2. A dotted eighth note would be 3 out of 4 16th notes. So it adds a 16th note duration to the eighth note to make 3 out of 4 for one beat instead of 2 out of 4 for one beat. So it's more like 1 2 3 1 2 3 1 2 3 1 2 3, and you can get sort of syncopated rhythms out of that. That's a bad explanation for a dotted note, but yeah, it adds half of its duration to its full time value. So for a dotted eighth note, given a constant note frequency T note, I can play, we'll play a note, which I did up here. We'll play the eighth note duration, added on to the 16th note duration. So that's simple enough, and that will add half of its value effectively to itself to play. So I've dotted eighth note there, and the only other thing I think I added was a triplet. Special tiny triplet function. Yeah, right there. Yeah, right there, a little triplet note function. We'll add more triplet functions. Okay. So what a triplet does is not enter in weird codes there. These will be void as well. Void eighth triplet. This will be given notes. I'll just give it 3 notes. That's fine. I was like, do I want to make it an array or another? No, I just gave it 3 separate notes. I'll do note 1, note 2, and note 3. Note 3, so constant, note 3, we have note 1, this will be note 2. Okay, so a triplet will play basically 3 notes in the duration of 2 notes, if that makes sense. So here the quarter note gets the beat, so every 1, 2, 3, 4. An eighth note would normally be 1, 2, 1, 2, 1, 2, 1, 2, 8 approximately. So this will play 3 eighth notes in the span of 2 eighth notes. So instead of 1, 2, 1, 2, it'll say 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, approximately. But it'll take up 3 of these notes. Since it's an eighth note triplet, it'll be 3 eighth notes in the span of 1 quarter note, instead of normally 2 eighth notes in the span of 1 quarter note. So it'll go triplet, da, 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 da. Yeah. Instead of going dun dun dun, it'll go dun 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 dun. It'll be a triplet. That doesn't make sense, but music's like, you kind of got to hear it and feel it, man. We can't explain anything. I'll say 3 notes in the span of 2. That might make sense. I separated it to be easier to read, eighth triplet, so this will be in the span of 1 quarter note beat. So I guess I could do that. Quarter note duration. And if it's 3 within the span of 1 of these, then this will be divided by 3. So we can do that. So let's set temp equal to that. And, oh, we can just do, I can call play note, or I can call play eighth note for this. If I do eighth note, it'll call play note anyway. Oh. But to make it easier, even though it's more overhead, I'll just call eighth note. That's probably not how you spell eighth either. Isn't 8 like with another H? Have I been spelling eighth wrong the whole time? Probably. Oh well. You can English majors can hate me even though I speak English, so. We'll play eighth note for note 1 for the duration of this divided by 3. Basically playing each note for 1/3 of what the regular note should be, and all 3 will add up in the duration of 1, and we should be good. So dotted notes play for their time duration plus half of their time duration. Triplets play 3 notes in the span of 2. Okay, I think that makes sense, and that was the last one I had, so let's see, it does not compile. Too many arguments to function call. So we can't call eighth note because it doesn't take in, yeah, the duration, yeah. Duh, that makes sense. We'll just have to call play note then. Right. Play note for duration. Yes, okay. And I program Python too much and don't like semicolons. I don't program Python at all. That's just an excuse. And it compiles. Okay, so let's actually do stuff with that. Which was sound test. Yeah, so that's in a separate file, so I'll include that here, make it a little awkward, and that's okay. So let's do sound. Italian plumber brother, is that what I called it? I think that's what I called it. And that's all that code that was in there, and then we'll disable. So this is just an example, you know, of what you can do. And I gave it quarter, and I called it different things. Yes, I did. the DS's were uppercase, and I made them lowercase s, and quarter is on all uppercase because it was an enum. Okay, so I do have to change some things. That is all right. Oh, this is fun. S, uppercase. Let's see, the uppercase S's are only in the notes, correct? Actually, there's not that many of them. Sorry, do S, S, S. Where's that one? G sharp. Mario is very easy. It was just a lot of things that were repeated. This one is interesting right here, where I have duration over 3 and 6. That was, I think I did that for this specific measure here, because that was near, that's 2 bars off from the end. I separated this by bars. So that's here. Yeah, that's this triplet here, this A, this B to this A. Because if I just went up to this, these two would be, there wouldn't be a rest in between, in between these notes. So I kind of had to play, I played this for the triplet duration, and then I played this A for half of the triplet duration, which would be over 6 instead of over 3. And then I did a rest for half of the triplet duration, and then I did the same for the next note, so that these would still line up as a triplet, but they were only playing for half their value, and then with rests for half their value. So you get do-do-do instead of do-do. There's rests in between. That's why this looks really funky. But that should enable the last triplet there to play. Okay. So fingers crossed this sounds all right. If it's too slow the first time around, then I'll just cut that out of the video and you'll hear the second time where it sounds okay. But let's hope this sounds decent. Nindendo, please don't DMCA me. My channel doesn't make any money. So yeah, don't do that, please. These are connected too. I didn't set the rest in between, so that sounds off. But you can see it if it's a little slow, yeah. But it still sounds pretty accurate. So the notes play. So you can play square wave sound with single voice. So it's pretty good. And yeah, I look forward to getting copyright claimed and copyright struck for something. So that'll be fun. But this is a good example. I think the volume's probably okay, right? Yeah. If it's too low, I'll raise it. Too high, I'll lower it. I don't remember where I'm at here. I think that was here. I just played these repeated sections. These are repeats, right? Just played those twice each time. So this should be this line. Yeah, that line's awkward to play. So there you go. I know I talked over it and that was bad, but you can always just boot up Mario yourself. Or Italian Brother Man yourself. But that's an example of stuff you can do with the just square wave sounds, resting and playing a little sort of hopefully useful abstraction for playing different notes for different durations. And yeah, of course the source code for this is going to be in the description. The video is going to be, you know, added to the main repo and everything. And yeah, hope you enjoy. That is the keyboard IRQ1 over this video and the basic PC speaker sound. I've been meaning to do this. I haven't because I've been busy with a lot of live stuff, but I've been meaning to get virtual memory and stuff done, and I've been researching and having people help me out with more stringent QEMU flags and emulation things to work on actual hardware. So stuff I do now does not work on actual hardware. Particularly the disk code is made for parallel ATA, not serial ATA, and HCI support and stuff is not, you know, I haven't done that. And eventually I want to do UEFI and things as well, but I'll probably flesh out this legacy boot OS first. The next video I want to do over this will probably be virtual memory. I do want to get into that so that I can load things at runtime with malloc or memory map, and then I can flesh out the editor and make an assembler and edit the OS within itself. Maybe, hopefully, we'll see. Maybe not. But I want to go towards that. So I'm gonna try to do virtual memory, and I may sneak in like graphics, like a double buffer for our screen, and maybe improving graphics a little bit, because I know graphics test is broken now on anything that isn't 1080p, or if it uses too much memory, it crashes anyway. So I might mess with some graphics test things, and maybe drawing Bezier curves or something to have something to show, maybe 3D, I'm not sure. But other than that, I want to get into virtual memory. If not, maybe also making a couple of C programs to build out our files instead of using the shell to be a little bit more portable. Like Windows and other operating systems don't have the same linkers, the same, shells. I might make a C file to fill out stuff with blanks to the next or zeros to the next sector boundary, stuff like that. Little utilities that are fun. And if not, something to make the disk image itself. But yeah, maybe I'm leaning towards virtual memory for the next video. But if there's anything you want to see, let me know. I'm more than happy to look into it and do it. Appreciate you watching. And yeah, I'll see you on the next one.